This is open for discussion. Tom?
You mentioned the rather remarkable statistic that during the time of the Apollo program, that 4% of the U.S. budget was spent on NASA. Now, I think you said something like
0.6. Yeah.
0.16. Yeah. So that's a big change, and one has the feeling that a lot of that had to do with the sense of adventure that you spoke of, and that you saw today as being the province of the private sector for achieving that sense of adventure. So what I'm wondering is, well, first of all, you didn't really say whether you thought it was a good thing or not that there was a lot more money being spent back then, and I'm wondering what is your opinion about that, and whether, in order to get governments to spend money, whether, in spite of the lack of scientific value in sending people into space, that in order to get governments to invest, you might have to become part of that adventure.
Well, of course, the Apollo program is motivated by superpower rivalry, not by science, and when the Americans had beaten the Russians, there was no motive for continuing. I personally don't think it's possible to justify a huge publicly funded manned space flight. If I was an American citizen, I would be against it. And I think the reason why I'm more positive about the private funding is, first, it's private funding, but secondly, because it's private, they can accept higher risks. The trouble with the NASA post-Apollo program was it was very risk-averse. They launched the shuttle nearly 140 times. There were 2 failures, but each was a national trauma, which delayed the program by 3 years. So in practice, these astronauts are prepared to accept higher risks, and it was a big mistake to present it as routine and safe. So I think it's the private companies which can take the risks, which the United States or Europe won't impose on civilians who they're paid for. And that's why I think it has to be left to the private sector, because, as I say, it's only a spectator sport and an adventure. There's no practical purpose. And we will cheer them along, just as we cheered along that amazing Russian priest who went around the world in a balloon just last month. There'll be crazy people like that, but we'll cheer them on, and they will be the people who will settle on Mars and perhaps lead to the post-human evolution that will start there.
Yes, the romance of science and the adventurism and all, that is going away. The high conservatism coming in the world, as science is concerned, there's not as much excitement. Even in big countries, which I won't mention the names, are doing that. I am very, very particularly about the rest of the world. If you go to the developing world, for the last several years I have been campaigning, as you know, how to get them to invest something in science. Very few countries even invest 0.1% of the GDP on science in a large number of countries in the developing world. So I think the academy of this kind should do something about getting science itself as an important thing in parts of the world, in most parts of the world, including the advanced countries. Science is not getting the importance it used to get some years ago.
Well, of course, space is high profile. Indeed, in India, you're high profile, and the fact that Indians have sent a probe to Mars, that got public interest. That was unmanned, of course, and I think it's not true that it has to be manned space flight. Most of the press coverage of space in the last few years has been of unmanned exploration of the planets and the Hubble telescope, etc. The space station only made the news when Chris Hadfield, the Canadian astronaut, played his guitar there, or when the toilets didn't work or something like that. It's not very glamorous. But if you want to make science glamorous, I think some of these unmanned projects are, but of course more generally there are huge challenges for instance, clean energy for the world. And I think one thing which was a benign outcome of the Paris conference last year was a commitment by 20 countries to double their R&D into clean energy. And that's the kind of thing which is inspiring, because for young potential engineers to try and achieve clean energy for the developing parts of the world, so that in India you can afford to go directly to clean energy and don't need to replace smoky stoves by coal-fired power stations. That would be great. So I think there are exciting challenges, and space is just one of them.
Again,
Professor Rees, I would like to know your opinion about the role of Wernher von Braun in space technology.
The role of Wernher von Braun?
Wernher von Braun.
Yes. Well, I mean, he was a historic figure, wasn't he, in the early development. And I also noted that just last week, an American called Mr. Ramo died at the age of 103. And he was one of the great American pioneers of the Atlas rockets, etc. But even before that, it was von Braun, but it was Ramo who was one of the real pioneers, and he just died this week.
He say positive things?
no?
Yes.
Yes? Please?
Sorry.
Happen. What I would like to say is that there will be always a limit to a nation irrespective of its economic strength, with respect to how much it can go. This certainly leads to certain level of cooperation and collaboration. One of the reasons India does some of these missions like Mars and Moon is primarily to establish a credential, so that in the future, when we have to be a part of a global community undertaking a major mission, you can qualify yourself because you have established certain capability. And I think whichever country does this level of activity, it is not going to go beyond a point, even India is concerned. Even with respect to the space station and manned missions, the question is how far we should go. We could try 1, 2, but the huge space station, we could then qualify ourselves to be a part of it. So what I'm trying to convey is the fact that this is going to be a pattern in which large-scale collaboration and collaboration between countries, like-minded countries, could become the way in which the space can be pushed forward. Otherwise, it can get into a stone wall at some point. And there are very clear examples from the history to be learned. It might be very useful for the academy to look at the models for the world to take forward, because this is going to be a future. And even in areas which are climate change, survivability, everywhere space comes into picture. I think we need a separate session only discussing the strategies for pushing the space program, space activities of the human endeavor in one of the future sessions.
Yes, I'd just like to say that, of course, it is a collaborative endeavor and it lends itself naturally to collaboration. And I can certainly imagine that when it's possible to have robotic fabricators working up in space, assembling large lightweight structures under zero G, then there will be perhaps international collaborations to construct huge solar energy collectors and things of that kind in space. Exploration, of course, is already done internationally, but I still am unclear whether this will ever involve sending people up there. I don't know if Lisa wants to say anything. But,
Stanislas Dehaene?
yeah.
Yes. was wondering if you could say a word about the pollution of space and whether we have reached a stage where it is already problematic for new satellites, for instance, and what we can do about it.
Yes. Well, there is an issue of space debris, which is accumulating in low Earth orbits, and it's aggravated when, for instance, a satellite explodes, etc., and you get lots and lots of fragments. And there has been a concern that there could be a sort of runaway increase in the amount of debris in low Earth orbits. Higher up, it's okay, but in low Earth orbits, people are already thinking about ways in which one can somehow remove most of the debris. And certainly when spacecrafts are launched now, there has to be a plan for how to dispose of them. That's certainly true for big things like the International Space Station, the Hubble Space Telescope, etc. You either have to put them up to a very high orbit where they will stay, or have some sort of controlled descent so that they land in the ocean. But the debris is a serious issue for low Earth orbit, because even a chip of paint moving at 20,000 miles an hour could cause damage to a spacecraft.
Okay. Professor Shu?
Yes. This is a comment, not a question. It's regarding romance and science and many other things. If you think about what's been happening in science, we just heard this spectacular presentation in neurobiology, one part of it. And if you think about what we're going to learn in cosmology, you think about what we've learning in chemistry and material science. It's absolutely spectacular. Exploration, space exploration, as Martin Rees said, is like going to the North and South Pole. It's very human, very understandable. Less understandable to the general public when you learn about not the average plasticity of a child, but the plasticity what happens when in your 20s and 30s and 50s, you lose your sight and your brain begins to rewire. And the plasticity even in your 60s and 70s I find to be startling, and I hope it's going to continue to be startling. But let's go back to the biggest romance. It's not a space race anymore. The thing facing us is this threat to our climate, the risks of climate. Surely there's not anything more challenging for science and technology to concentrate on than that. Despite all the other wonderful things that are happening in things that take my breath away, from high energy physics to neuroscience. This is something which should appeal to the basic scientist's romantic vision of what needs to be done. It's exploration, but it's also something that society really needs. That's my comment.
Well, of course, you speak with far greater authority than the rest of us, but I would like to echo that, and indeed that's why I mentioned this proposal for doubling the R&D level into clean energy, because the exciting new technologies involved in clean energy, smart grids, batteries, and all that sort of thing ought to inspire young engineers. And why shouldn't the level of R&D in those areas be on the level of medical and defense research? It's now far lower.
Yes. Now that's worthy of not 4% of a science budget, perhaps 10 or 15%.
Sure. Yes. Mm-hmm. Yes, Lisa.
Last question, Mrs. Kaltenegger.
I actually would like to comment on what was just said. And one of the key points, and we'll talk about this a little later, of the exploration of other planets is to understand our own better by having more and more data points to even be able to understand basic scientific or basic tectonics projects or geochemical processes on the Earth better by actually having a variety of planets with different masses, different densities, and different evolutionary stages to underpin our model of our own. So this exploration that Martin just beautifully mapped out is on one point our venture into space, this adventure where we're going, the curiosity that has always served humankind very well in developing. But on the other hand, it is a crucial part for us to understand how our own planet really works. And I think that combination, as was pointed out by Steve or by Martin, is what's the real compelling thing to not forget about space exploration, because there are a lot of problems we are faced with that sometimes, when seen under a completely different point of view, present a solution that would have not been easily found if we concentrated on the problem heads on here on Earth. And I think that's the beautiful combination of the different research brands, and especially astronomy has a few generation view and a few of the big pictures by default, because most times we don't get very good data. So we have to be very inclusive and look at the big picture and the patterns that develop.
Yes. No, I completely agree, and people may not know that Lisa directs the Carl Sagan Institute at Cornell, and Carl Sagan, of course, exemplified the inspiration of space more than anyone else.
Martin, and I will call the next speaker. Yeah, we have to keep the time, Antonio. So Guy Consolmagno from the Vatican Observatory on exploiting solar system resources. Thank you. I'm sorry, but
yes.
the time is out, Antonio. So maybe we come back during the general discussion. Telegraphic.
I apologize, but I cannot avoid recalling that Professor Rees should have added to all this very large spectrum of topics in the International Space Station. There is a very important experiment, AMS, Antimatter and Space. One of the greatest mysteries of our existence is how it happens that in the universe there is nothing concerning antimatter. And the evidence so far has always been indirect. Now, there is an experiment at the International Space Station where for the first time we have direct evidence that there is no sign for anything like antimatter in the universe. And believe it or not, we cannot forget these fundamental questions. We speak about very interesting topics, but we should not forget that there is this very important experiment in the International Space Station, which tell us from indirect evidence, for the first time in human history, the direct experiment for the non-existence of antimatter in the universe, anti-star, anti-galaxies. But antimatter exists, as we have demonstrated in 1965 at CERN, with the production of the first example of antimatter. Don't confuse antiparticles with antimatter. Thank you.
So, Guy Consolmagno, you can have the floor now.
If we could have the first slide.